Well, over here we have a graph, and we want to state this function. So we know it's going to look something like this. Our function is equal to, well, we know there's going to be three pieces. We're going to have to create some inequalities to determine when we use each piece. I'm going to start on the left. I'm going to work my way right. Right here, everything kind of changes. Right here, everything kind of changes. So I'm going to use those same imaginary green lines to help break this up for us. Right here, this piece to the left, the first thing I'm going to get is the slope because I can't see exactly where it's going to cross the y-axis. And it might help if we use 2 points. This point right here is -2, -6. And that point right there is -1, -3. So now I can see it's going up 3 and it's going over 1. Up 3 over 1 means our slope is going to be 3. So when I'm writing my function, I know it's going to be 3x, the slope in front of x. And if I continue this up 3 over 1, I can see it'll cross the y-axis at 0, at the origin. So this is 3x plus 0, and I know I can write that without putting the plus 0. It will be understood to cross the y-axis at 0. So my equation of my line right there would be 3x, and this is true for all x values less than a -1. It cannot equal, notice that is an open circle right there, it cannot equal at -1, but it can be any x value less than that. Moving on to the next piece, I can clearly see this one has a y-intercept of 0 once again, and this one has a slope of -1. I'm going down 1 over 1. So the equation is simply -x or -x plus 0, but again, I don't need to write that. And this is between two x values. Again, I have that bound of -1, and over here I have the boundary of 3. So this is all x values greater than or equal to a -1 and less than 3. So all things in between that can't equal the 3, but I can equal the -1. And finally, I have this third piece right here. It looks parallel to the previous one, and that is true because I can see that the slope is again going to be a -1, down 1 over 1, down 1 over 1. But when I continue this to the left, I can see that this will cross the y-axis at 7, so this is -x plus 7, and this is true for all x values greater than or equal to 3. Once again, it can equal at 3, and it's all x values greater than that. Finally, let's take a look at our domain and range. The domain, all real numbers, once again, notice it's pointing to the left, it's pointing to the right. Any real number I can think of satisfies these three inequalities. So there's no excluded values, nothing like that. Our range, well, we're pointing down, so all these y values are true. We're covering everything, and our highest y value is a 4. And it can equal at the 4, so this is all y values less than or equal to